All right. Raise your hand if you were able to successfully complete this DOM. Really? Ooh, outside the box thinker. Very nice. I didn't think about that. I didn't think about that. That's true, though. That's true. However, I had to do a thing in college where there was a similar thing to what you're talking about. Our teacher asked us to put the pencil on the paper, and he said, mark all over the front and back of the paper without picking up the pencil. You can't pick it up, but you have to connect a line that goes all across the front of the paper and the back of the paper. And I couldn't figure it out because I'm not four-dimensional enough. But apparently you had to like rip the paper and like twist it and tape it together, and that way if you did it, it would kind of just crazy. But you are an outside-the-box thinker, and I like that. Okay, well, most of you probably got that you couldn't do it. And that is correct. You can't do it on one side of the paper. Really? Touche. Touche. Well, oh well. I didn't expect to be corrected so many times today. But you all are all right. And you're going to prove me wrong many times this year. Don't ever think if I'm wrong, you can't say it. I like being proven wrong. It means I'm learning something. What I expected before I was proven wrong by, hold on, working on names, Brandon and Sage, was that everyone would try to put like a point here and a point here, and of course I would have been able to walk over there if I wanted to and draw a line right through them. Because any 2 points on the same plane, now we're going to talk more about what a plane is in a minute, any 2 points on the same plane can be connected into a line. Yours will be on different planes, again we'll talk about that in a minute, and yours will have a hole in your plane, we'll talk about that too, but if you're just talking about one flat surface, 2 dots, no holes, no flippages or anything, it's impossible. Any 2 dots can be connected into a plane. Hint, hint, that'll be a test question on your first test. I believe it'll say, how many lines can you draw through any 2 given points? Now, could I have angled, now, ideally this would be straight, but I'm not a very good artist. Could I have angled this line any other way and it's still gone through those 2 points? No. There's exactly one line you can draw through any 2 given points. And that's how I believe your test question is worded. It'll say, how many lines can you draw through 2 points? And then there will be variations of that question. And the answer is 1. Okay, today is a vocab day. We're going to have lots of days where basically all we're working on is vocabulary, because vocabulary geometry is like the most important thing. Because I'm going to be asking you things later on, like find the points on the plane that connects to the ray. And they're easy questions if you know what the heck they're saying to you. So today, we're going to work on vocab. Section 1.1, points, lines, and planes. If you're a note taker, that's what you want to nibble your notes. If you're not, that's fine. Points, lines, and planes. A point has no dimension, and it's just represented by a dot. Now, we're going to be, in this class, working a lot with the coordinate plane. Raise your hand if you've ever graphed before, like points, lines. Do you ever put anything on graph and then just, okay, well, that's good. A point is just any spot. Any spot. B, C, D. Those are all just points. That'd be point A, point B, point C, and point D. Questions about that? Points are rather simple. The whole section? It was 1.1. Points, lines, and planes. Yes, ma'am. Yes. Let's take the red pass. All right. A line has 1 dimension. It is represented by... I apologize. Well, that's okay, because while you write that, I need to actually come get your DOMs, because it's Friday. I'm going to take them up on Friday. So have your DOMs ready for me to pick up. I'll tell you what. I'll go ahead and put this definition with the next one, and you can get them both down if you want them. There you go. There's the one that was on the previous screen, and the one above it's the next one if you want to get that down. You don't have to, but if you're a note taker, which is commendable, there they are. Make sure your names are on everything that you turn in. Edward, it's okay this time, but ideally next time put like down at the top. Thank you. Okay. Give me one piece of it. Got it. All right. A line has one dimension and is represented by a line with two arrowheads but extends without ends. So this is just going to keep going on forever and ever and ever in those two directions. Not really much else to say about it.
Teachers and students, pardon the interruption. We are going to call for a few schedule changes. And we'll do that periodically, so there will be some interruptions. We're going to start with the seniors right now.
So, line made up of at least 2 points, just keeps going without end. We'll talk more about lines in a bit. Because the complicated piece of the day is a plane. A plane has two dimensions and is represented by a shape that looks like a floor or a wall, but extends without end. The front of your sheet of paper is a plane. Anything flat that just expands is a plane. My smartboard is a plane off my screen. My wall is a plane. My marker board is a plane. The ceiling is a plane. Anything flat that goes off in two directions, like length and width or something. Now, similarly, the way I said earlier that any 2 points I can draw a line through. Similarly, any 3 points you can connect with a plane. Any 3 points you can connect with a plane. So this would be plane. Well, if they ever label a plane for you, I guess you can call it that. But a more safe way to do it is just pick any 3 points on that plane, and you can call it plane ABC in this case. Now, what if they had put like 1,000 points in this plane? Point D, point E, point F. Exactly. Pick any 3 of them in any order. Doesn't matter. Whatever points are up there, pick any 3 of them to name your plane. Plane FBE, ACB, ADF, whatever. No wrong answer. Some of your tests are going to have something like this, and they're going to say, what is the name of that plane? Well, you could give me like 30 different correct answers. The only way you could miss a question like that is if you didn't give me 3 points. If you were to give me just 2 points, that's not a plane technically. The reason it's not a plane, like you take point BD, well, I could do another plane. What if I took some kind of vertical plane slicing down that way that would contain BD? BD does not specify that exact plane. You need to pick 3 points that are not all on the same line. So BDF, CDF, as long as you give me 3, and they're not just all on the same line. Okay. Everybody got this that wants it? Collinear points are just what they sound like. They're points that share the same line. If you have a line with multiple points on it, those points are collinear. Similarly, coplanar, points that share a common plane. If you use your just context clues of those words, co, cooperate, line, on the same line, collinear, they share a line. Same thing for coplanar.
Need the following students to report to lab 16, 17.
Questions about that vocabulary? Click. All right, let's finally get to something we can.
Any junior, A through C, that needs to
Give two other names for line PQ. Someone raise your hand. Line PQ. Wait. Two other names for PQ. Oh, and for plane R. Oh, all right. What are some other names? You know, I'm not entirely sure if that's written correctly, but oh yeah. What's another way I could label line PQ here? QP. Just flip the order. Order doesn't matter. Now this one's confusing. See, I would have preferred if they had put another point on here for you to choose, because I know you guys right now are like, well, like this was point W. You could have WP or WQ or QW, and that'd be correct. But I think what they wanted you to notice was they actually pre-labeled this line N, which there you go. And you could just call it line N. I'm assuming that's what they're going to say the answer is, and they are. QP and line N. What about for plane R? What are two other names for plane R? VSP, any 3 points. So what's another one, someone? VPT, very good. The only three-letter combination you could have given me that would have been incorrect is anything with a Q in it, because it's not on that plane. And you could not have given me SP and P. Again, you can't give 3 points in the same line because they don't dictate a unique plane. Here's what I mean by that, by the way. You might be thinking, well, what is he talking about? Well, looking for a plane. Take three of these dots here, right? Boom, boom, boom. ABC. He said, that's plane ABC. So I assume you're talking about the wall. Well, what couldn't I like stretch like a sheet out this way? Like a second ceiling lowered that would also connect those three? Yeah. That's why if 3 points are on the same line, they don't uniquely make one plane. So that's why you couldn't have told me SPC, but any other three-letter combination would have worked. Also, plane R. Looks like they went ahead and labeled it for us. Oh, hold on. There we go. All right. Oh, dang it. I already answered which point B. Hold on. B, name 3 points that are collinear. There's only 3 points on here that are collinear, and that's S, B, and C in any particular order. And name 4 points that are coplanar. There's only 4 on here that are coplanar. What are they? That's right. They all share that common plane. Although technically, S, P, T, and Q could all share a common plane as well, but that's not shown. So, and we're mentioned. So we won't talk about that. Questions about the answers for either of those two? This is going to be the kind of thing you're asked to do today. Look at a picture, tell me what you see. Questions about anything you see on the board? All right. A line segment is basically it's just an abridged line that stops on both sides, and you label it as its endpoints. Now, unlike a line, if I had put points C, D, and E all in the middle there, I'll just put point C for right now. The only correct ways to label this segment is AB or BA. If you were to label this segment AC, and please notice it does not have arrows in the end, that's how you differentiate it when you label it. If you had labeled it AC, you would suggest that it stops right there, and it doesn't. So remember, the endpoints are what you have to label a segment by. AB or BA, and that's it. A line had 2 arrows on the end.
sophomores. Last name beginning with A through C.
Line had arrows on the end. A segment does not. Questions about that piece of vocab? Click. All right, now the reason I'm going back to a line is because notice a line has two arrows, extends in both directions. We've actually already written this one, so you don't have to write it again. Rays are like partial lines. They go off infinitely in only one direction. And there's a very specific way you have to label a ray. A ray has what we call, well, it doesn't look like they call it here, but an initial point and a terminal point, which is basically a starting point and not an ending point, but a point that it goes through. So when you label a ray, like this would have to be ray AB, with ray having the non-arrowed side and B having the arrowed side. If you flip those, it doesn't say the same thing. This is ray AB, this is ray BA. They're extremely different, not the same. And here's how they would be labeled. That's the top one, that's the bottom one. Questions on that one? On that slide? No questions? All right, we're just rocking and rolling. Opposite rays, which is basically just a line. But if you have one ray going this way and one ray going this way, then they form opposite rays. Here you have opposite rays CA and CB. And that's the only pair of opposite rays because they can't overlap. CA and CB in this picture are opposite. And you can tell they're opposite if they form a line and don't overlap at all. What do you think I mean by they can't overlap? Somebody tell me what two rays up there are overlapping with each other. I'm sorry? Yeah, exactly. AB is this ray. BA is this ray. If I said AB and BA, you have two things like this. And this whole portion in the middle is counted for twice. So they could not be opposite rays. But CA and CB, and the important thing to notice about opposite rays is that they share the common initial point. Notice, CA and CB both share a common initial point right in the middle. Questions about opposite rays? If there's a bend to it at all, they're not opposite rays. They have to be completely straight, forming a straight line. Okay. Someone raise your hand and tell me, what's another way I could label segment GH? Segment. Please notice it's not line GH, it's segment GH. What's the way I could label it? Thank you. HG? Next time raise your hand. Yes, that's right. Name all rays with endpoint J. There's 4 of them. With endpoint J, what are the 4 rays? Caitlin. J-E. J-E. There you go. J-E, J-G, J-F, J-H. And what's the initial point for all 4 of those? Okay. Then you'd have 2 pairs of opposite rays, and those would be what? Someone? What's that? They are collinear, but what are the actual rays that form the opposite rays in this picture? There's 2 sets of them. I'm trying to get a sample in. Malik. JF and J what? Close. They need to be going in perfectly opposite directions. So JF and JE, and then JH should be opposite with JG. You got it. Perfect. Perfect. Questions about any of those answers? This is just a whole lot of writing for what we just said. Questions? All right. Let's see, what else we got? What's another line for segment EF? FE. Are HJ and JH on, are HJ and JH the same ray? Why not? Why aren't HJ and J, I'm not saying you're wrong, I just want you to explain. Because it says, they explain. Exactly. So order they're in. One of them starts here and shoots that way, and the other one starts here and shoots this way. Completely different. Order matters for rays. That's the only one that matters. Lines, planes, and segments, they do not. Intersect. Intersection, you guys have probably been using this since you've been watching your parents drive a car for the last 15, 16 years of your life. When two things cross, two lines intersect at a point. That's the important thing to take away here. Two lines intersect at one common point. Two planes intersect along a common line. And a good way to visualize that is like, where does the ceiling plane meet this wall plane? Where does the ceiling plane meet the wall plane? Yeah, along that entire crease right there, that entire line. Two planes will always meet along a line. Two lines always meet along a point. Intersect. Use the vocabulary word. Intersection is where they cross. Questions? See some people writing notes, so I'll give you a second. These vocab days, there's usually so much vocab, they often take longer than a day where we actually learn some like math stuff. But geometry is really more vocab than it is number crunching, so if you're not a huge number crunching fan, then you should love this class. Alright, here's just some sketching. If you wish to sketch on your own paper, you can, but we're just going to discuss it. Sketch a plane and a line that is in the plane. What do you think that means? A line in the plane. What's that? Yeah, well, right. A line in the plane would be like something you would draw right on the paper. Whereas, if it was like going through the hole, like Sage mentioned earlier, something like that, that would not be in the plane. That would just be intersecting the plane. So the first drawing would look like that if you were to have drawn it. A plane and a line in the plane. Sketch a plane. A line does not intersect the plane. Does not intersect it. What do you think that means? Doesn't go through it, never touches it. So therefore they're going to kind of be parallel with each other, which is a vocab word we'll get to later. There is a plane and a line that does not intersect that plane anywhere. And then lastly, one that intersects the plane. What do you think that's going to be? Just going to slice right through it. Just like that. The book likes to use dotted lines to represent things that are behind it that we shouldn't technically be seeing. Because, you know, they're behind. But hopefully that won't be confusing when you're looking at diagrams in the book. Questions about anything you see on the board. You are going to have a sketch problem or two today. You don't have to be a great artist. If I see the general concept, that's fine. Alrighty. Here's another sketch one that I just thought we'd look at. Sketch two planes that intersect along the line. I could never draw that. Ever. And I won't ask you to draw that. But that's what that would look like. Two sheets of paper kind of slicing each other in half along a common line. What is... If I asked you where those two lines intersected, and you had to tell me by like writing it down, how would you describe where those two lines intersect? In the middle of, yes. But what I was really meaning was Trip. Yeah, line M. These two planes intersect along line M. Very good. That's a very geometric answer. Let's see, we're almost done. Use the diagram at the right. Name the intersection of line PQ and line K. Where do PQ and line K intersect? I'm going to pick people at random. Some people are carrying the load. Stacy, where do PQ and K intersect? Very good. Point M. Where do plane A and plane B intersect? Ooh, a little more complicated. Elijah, want to take a stab at it? Where do plane A and plane B intersect? Want to phone a friend? Who do you want to phone? Very good. here's the key there. If it ever asks you for the intersection of two planes, you know it has to be an entire line. So you need to find which line these two have in common. And you could have said line K, line NK, if you were to view K as a point, that would work too. So line K is the better answer. So very good. Very good. And lastly, name the intersection of line K and plane A. Where does line K and plane A intersect? At what point? Oh, right, you pick somebody. Justin. Well, actually, part of that's correct. But whenever I ask where a line and a plane intersect, it'll just be one point. So where does that line intersect with this plane? Yeah, point M. Now, actually, you weren't wrong in that any point along this line could have been an answer to it, but since they only gave us one, that's all we could say. The only problem with Q is that it's not on line K. So the only thing they gave us in that picture that was on both was line. Okay. Or point M would have done fine as well. Okay. These are kind of different than anything we've done, but they're algebra review that's thrown into your assignment today, so I just wanted us to take a look at them, make sure that we know what we're doing when we get there. You are given an equation of a line and a point. Use substitution to determine whether the point is on that line. Who can tell me what I need to do? Yeah, exactly. The first letter is going to be, or number is going to be X. Second one's going to be Y. Just plug them in. So this one, that's going to be 1 for the Y, equals 5 minus 4. Is that a true statement? 1 does not equal 5 minus 4? Yes. If it's a true statement, then your point is on the line. That means this line contains this point. What about number 31? We plug that in. That's negative 5 equals 3 times negative 1 minus 2. This is the Y, this is the X. Is that a true statement? Yes, it is. So what's under the black box? On the line. Very good. And the last one, if you did it, you would get 1 equals 3 times 7 plus 4. Is that a true statement? No. So that would not be on the line. And that's all you have to do when you get there to those problems. On the line, not on the line. Or if you just put true, false, whatever, that's fine too. The only other kind of problem you're going to have, and this is the last slide, is graph the inequality on a number line. So you're just going to have to draw a few number lines. And you don't have to like do 30 numbers on these. Just put the relevant ones. Like 33. 3. Am I greater than or less than 3? Less than, which means it is a whole dot at 3 going left or right. Very good. If it's less than, it goes left. So what it's asking, when you draw that, is that a segment ray, multiple rays, a point, or a line? Yeah, a point, one thing. Very good. It is a ray. I'll just go ahead and stay on the same. Well, no, I won't, because when I do that, that'll happen. Uno momento. Let's just draw these real quick so that we look at every possible scenario. 4 and 7 looks like it spans from -7 to 4, but it looks like it stops there. So what shape would that form? Well, I didn't draw this very well, but what shape would that form? Very good. And last but not least, let's look at number 37. Oh, let me go ahead and cover this segment. Let's see. We have -1 and 5 greater than -1. So all of this. And less than 5. All of this. Now, if we were to put that whole thing together, what would be the easiest way to describe what that is? You know, I could see it as both. Technically, I could see it as rays. I think it's interesting. I know, because I made this assignment, that they want you to say line, but I would accept rays there as well. But if you look at it as just one collective thing that encompasses, I guess it would be a line. So I'll accept either one of those. Questions? Great. Now, at the top of every one of your assignments, please put the section number. That'll make these much quicker for me to grade. I can get it back to you quicker. So at the top of your assignment, label it real big, top middle of the page, 1.1. Every day you're going to put the section number big at the top of your paper, 1.1. And even though we've had 8 billion interruptions, we have like almost an hour to get this finished.